we'll just keep moving now. We're going to go to the third session, which is from NXP, and the speaker is Blendon Slade. So there he is, Blendon. So I'm just going to go do a quick intro for you. So Blendon Slade is the director of the General Purpose MCU Ecosystem team. He has over 30 years of experience in the DSP and microcontroller industry, where he has held design, application, and technical marketing roles serving industrial, mobile, automotive, voice communications, and audio processing markets. His team focuses on enablement of NXP ARM Cortex-M-based MCUs, working with partners and NXP's internal software teams to define and deliver complementary development tools and software solutions. Blendon is a graduate of the University of Plymouth, UK. He lives in Sunnyvale, California, and holds patents in debug technology. So Blendon's topic for today for his presentation is enabling great UI experiences on NXP MCU platforms with LVGL and RT Thread. Take it away, Blendon.
Thank you very much, Lance. I'm just going to try and share here. I don't know if I see the share option available to me yet, Kathy. So hopefully that's going to appear. Okay, I got it now. All right, so just bear with me 1 second, folks. Just got a dual screen situation and a little bit of window swapping to do. If I was in my office, then this would be easier, but we all know how things are going in that way right now. So any second now. There we go. So hopefully Lance can give me the nod and we can see that you can see my screen, Lance.
Yeah,
can you help me out with that?
All good.
Okay,
all
great.
fantastic.
Thanks so much.
Yeah.
So yeah, a nice long wordy title we have here. So it's all about enabling great UIs on NXP platforms using that great LVGL library and the very powerful RT thread, as you've just seen. So I'm going to go over a couple different topics here. So basically talking about why NXP is working with LVGL and RT thread in the graphics area. A quick overview of the software and UI design tools at your disposal. We've already seen Squareline today. I'll just touch on that briefly, but also another option we have. And then a review of the NXP MCU platforms and the one that's particularly in play for this contest that we're setting up for you guys to really get stuck in. So NXP has a very broad portfolio of microcontrollers and MPUs, but and these span from very low cost devices, and those could be devices that aren't really designed from the ground up to be a graphics MCU. They're just just an MCU, and then we have ones that are very high performance with a lot of extra hardware to really make a UI very powerful. And so to complement that, we need software that can enable the graphics across that whole portfolio. And there are options that come from the premium end that come down from MPUs into the high-end MCU space that work very well for those platforms. But with LVGL, you can really go from that really low resource MCU up to the top end, so you get a lot of reusability across the whole range of products. So we do work with several other partners. You can follow that link when we give you guys the slides and dig into that if that's an area of interest for you. But our primary free enablement strategy is all geared around open source graphics based around the LVGL library. So NXP has been committed to open source for many years. We decided to go in that direction from Jeff Lees, who is now retired, but was our leader in that our MPU and MCU edge processing business, and he was quite visionary in that regard. And so we're involved in many other projects as well. I won't list them all out here, but you can see throughout our SDK, which is our driver and software packages, that we make heavy use of open source software. Now, a few years ago, we wanted to explore how we could provide customers with a high performance library that was free and open source, because we had customers who in the past had picked a graphics solution and then the graphics company had gone out of business, or they just didn't like the lack of control that they had. They wanted the ability to contribute or to be much more involved. And so open source was a good direction to go for that, and LVGL was a clear choice. So you have a library that is designed by people that know what they're doing from the beginning to support low resource MCUs. And Gabor and his colleagues have a great understanding of embedded applications. It came out of the birth of LVGL coming from a guy who wanted to do these kind of things and knew exactly what he was doing. And the community is very vibrant. We have pretty good attendance here today. A lot of people very interested in LVGL. So it was a pretty clear choice for us. RT Thread, so if you know about NXP's microcontroller business, we do a lot of business in China. We do a lot of business all across the world, but China's a big important market for us. We have a great team out there. A lot of our chips are designed in China. And so we're very involved over there, and our team feels the pulse of the market and have seen RT Thread growing very rapidly in popularity. And we've seen how great the tools are now available for RT Thread and made huge strides in recent times. So there's multiple NXP platforms out there on GitHub. It's not only the ones we're talking about today, there's several others too. Here's the link to the BSP GitHub repository. And we have this historic and growing relationship between us and the RT Thread team to work together. Now, we've seen development tools here that Miko just demonstrated. NXP has its own Eclipse-based IDE as well. We also work with Kyle and IR tools and others. So I'm not going to go into the NXP development tools here because I think for a lot of the audience looking towards RT Studio is where they're going to want to go. But I did want to mention that in our SDK here, this is again a snapshot of how we put together, allow customers to put together packages with the different software that you want to include, all the different kind of platforms that we have that have LVGL support. So basically all of our recent M4, M33, M7 Cortex based parts all have LVGL enablement. And so you will see some of those supported in the RT Studio, RT Thread environment, but they're growing that enablement and that this relatively recent engagement with three-way engagement with LVGL is driving a lot of that. You'll see more enablement on our SDK in the short term, but that will develop over time. So this, along with doing a lot of work on our own to enable LVGL on our platforms, are also contributing back. So we've contributed hardware acceleration commits to LVGL for our hardware accelerators that I'll touch on in a few minutes. We also contribute back widgets and other things too. So we like to be a contributing member of the family, as it were. And we also designed a UI design tool called GUI Guide, which I'll mention in the next slides. And this presentation is really around microcontrollers, but we have done work on our IMX Cortex-A application processors running LVGL as well. There are cases where that's of interest, so we are doing work in that area too, but out of scope for this presentation. So GUI Guider. GUI Guider is a tool that NXP provides for free for customers just running on host simulators or running on NXP Silicon. It runs on Windows, Mac OS, and Linux. And it has built-in support for the kind of products that are either leading in terms of our most popular and newest products, or those that have graphics enablement. And so you can see those listed out here. And it's similar to Squareline. It is a WYSIWYG type editor, and you can run in a simulator, or you can just do press button downloads to the board and then see the same UI running on the board. And that's what the screenshot's showing here. So we developed GUI Guide. We started that work when Squareline didn't exist and there was no plan for Squareline. So there was no design editor at that point. So that's where we got started. We do intend to keep going with this because we want to do more in this area and help provide some of the best tools and tool options in the market. So GUI Guide generates code, and it generates code that runs in a single thread. So you can run it with RT Thread or any other RTOS or on bare metal, even though the current tool talks about output for free RTOS. That's only because the SDK example we have right now in our SDK is based on free RTOS, not because you can't run it with RT Thread. And the RT Thread team have examples of them running now where they can take GUI Guide output and put that into the examples. So a few more features from GUI Guide. There's a lot more. As I mentioned, it's a WYSIWYG editor. It works with LVGL widgets, and you can easily configure the attributes of those widgets and add events, actions, animations, and so on. You can import images and fonts, and we supply some demo applications for you to get started with. So it generates C source and header files. It can also generate MicroPython as well, and it generates a project output directly for the IDs shown here, MCU Expresso ID being our in-house GNU Eclipse-based one. And it has a built-in simulator as well. So we're continuing to add more things to GUI Guide all the time. And some examples here on the right are screenshots from demos that we built a little while ago using GUI Guide, and actually the design services from Gabor and his company helped us develop the e-bike demo at the top, and I think the middle one as well. So we work with Gabor and his team, a pretty creative bunch. So mentioning Squareline, you've already seen a very nice demo from Gabor here. Just to make it clear, NXP loves Squareline too. We have no agenda to push our GUI Guider against Squareline. It's a great tool. So we just like to give people choices. So it's an option, a good option as well. RT Studio, again, I'm not going to try and do a demo here, just to point out that the RT1060 board is supported by this environment now, and they've obviously got good enablement to get you running quickly, already very capably demonstrated by Miko. So just wanted to mention that here. So we flip over to the hardware side. If you look across our portfolio that I mentioned earlier, we have this very wide range of devices covering a whole range of different applications. The concept of crossover processors comes from an innovation we did a few years ago, where we have people at the MCU end running out of performance on flash-based micros due to the nature of the flash technology not being able to keep up with the logic technology. And then at the IMX end, where there's no on-chip flash, people wanting to get into lower power and lower price points. And the crossover concept comes in where we bridge those two worlds. And with IMX RT microcontrollers, they have no onboard flash, but they run very fast and can be a lot more power efficient and simpler to use than IMX devices. So most RT devices are running RTOSes or bare metal. Some can run Linux too, for those coming from the IMX direction down. But they offer a groundbreaking performance with our top end device now running up to 1 gigahertz. I'm not going to run through all these numbers in this table, but this shows you really the parts that are targets for graphical applications. All the IMX RT devices with 4 digits there, they're all Cortex M7 based, and you can see they run from 600 megahertz up to 1 gigahertz with a lot of on-chip SRAM. And various members of that family have graphics. In fact, they all have graphics acceleration in the ones in this table. There's also some smaller parts that don't have the graphics acceleration, but also have enablement for UIs where you don't need as much performance. And then the display controllers I'm going to run through in the next few slides. Under the heading of mainstream here, we have our 54,000 series devices. These are flash based and still give you pretty nice performance, especially for the kind of wide QVGA size screens, also fully supported, and they also have RT thread ports available as well. And at the bottom end, you're looking at devices that don't have any native displays or acceleration, but you can use SPI or Flexio, which is a special interface that we have that can support parallel displays. Quickly running through these display interfaces. So the one that comes from the older LPC devices, the 54,000 series, supports 16 or 24-bit LCD displays. If you get one of the kits that you'll see later, you'll see that works very nicely with that wide QVGA display we have there. And there's a DMA controller which is dedicated and helps offload the processor. And then on the RT devices, there's the embedded LCD interface here, which is a slightly higher performance version on that platform. And there's a further enhanced version as well, which has up to 8 layers of alpha blending, and alpha blending being a fairly onerous task for an MCU. So that hardware acceleration really helps. And then on the IMX RT1160 and 1170, and also on the IMX RT500, which I didn't mention, which is a kind of specialist part more towards the wearables market, but still available to everybody. There's MIPI DSi. So for those more specialist displays, like a wearable display or a lower cost or more compact type display, then, or one you're leveraging from the mobile phone market, MIPI DSi is highly desirable and gives you very high performance, very compact, and lower power. So we have a various different hardware acceleration engines. The Pixel Processing Pipeline, or PXP, is one that's in all our graphics-enabled IMX RT 4-digit parts, and this really helps with some key graphical operations. This is accelerated by the library add-on that we contributed to LVGL. So it gives you bit blitz, it gives you a lot of image composition options like alpha and color keying and so on. Disk color space conversions, again, something that MCUs are going to struggle with a bit, so it really helps offload. And then resizing and rotation. And then you also have the offloading of transfers to the LCD panel directly from the DRAM, so the processor doesn't have to do moves and copies to do that. And there's a diagram below to show you the various different elements. And then we also have OpenVG core in the RT1160 and 70, and in the RT500. This is a high performance 2D or 2.5D GPU. Won't run through all the operations here, but one of the key things is vector graphics. So that can make a massive difference in performance when you're doing vector type and scalable type displays rather than bitmap types. And again, we have a graphics library based on the VG Lite, which is Vivante's light version of OpenVG, which is pretty efficient and more portable than just going down to specific hardware libraries. So NXP has been working with Gabor for a long time, and we got several of our platforms through the certification process. We were one of the first boards through that, and so here's a list of those that are available with certification. And I think all the ones I mentioned already are there, except the RT1170. We haven't got that through evaluation first. One of the things about certification is the certification also depends on the LCD. Our LCDs tend to be ones that are a balance between cost and performance, so you can put a nicer LCD onto our boards and get to a higher level of certification. So we're looking at that for the 1170 because it's our top end, highest performing platform. And there's also a picture of the K28F here, because that's the one using the Flexio display, and that's one where a higher end display can be added to a part which doesn't have the native LCD drive interface. And just to mention, there's I mentioned much earlier on about how many platforms are supported in the SDK for LVGL, and those would use the SPI connected displays, the kind of thing you can buy from companies like Adafruit and Seed Studio, and so those are also available. But the platform of interest right now for you guys is probably this one, the IMX RT1060 EVKB. So the in the certification, if you look at that, you'll see that the one that's certified is 1060-EVK. But basically, in terms of all the graphics, it's exactly the same. There's some other features that have been added, like some audio enhancements to the latest platform, but in terms of graphics, it's identical. So this has the RT1060, which is just about our most popular microcontroller, with a Cortex M7 that's running up to 600 megahertz, megabyte of on-chip SRAM, but then a lot of other SRAM on memory on board as well. It has Cap Touch, of course, and an SD card socket. There's various audio interfaces available too, Ethernet, CAN, USB, all there. So lots of interesting peripherals to use with your UI application. And the links here are directly to the RT thread port, the BSP for this particular board, and also a link to an example as well. So we're hoping to see some exciting stuff running on this from you guys very soon. So just some other links as I wrap up. You can look at any of our boards here. We have, if you know the board name, you can just type it in direct like that, or just use search. GUI Guide, that's on nxp.com. You can go and check out the demo videos, or just download it and play with it. It's completely free. And if you want to find out more about other graphics offerings we have, that go to that link, and then you'll see further down the page there's a link to graphics, so you can see the various different partners and so on that we have available. So that's it from me, Lance. I don't know if anyone has any questions. I'm going to have a go at